So today I'm going to talk about rigid body kinematics, rotation about a fixed axis. So the first thing it's important that I get that is introduced is that, so when you have rotation, you have like, say a wheel, and this wheel is rotating. So this whole wheel itself is rotating about the center. But if you look at any individual point, a point can't rotate. So this point has a velocity going straight this way. This point has a velocity going straight this way. It's the whole body itself that's rotating, not a point on the body. So points don't have angular rotation, only the body itself does. And so I'm just going to introduce the idea of angular rotation. You've probably seen this before, but just as a recap. So you have some angle theta that the body moves. The angular velocity is called omega, and it's equal to the change in the angle over the change in time, so d theta dt. By extension, alpha is the angular acceleration. It's the derivative of angular velocity, so d omega dt. Or it's the second derivative of the angle theta, so d theta squared dt. So this is one and the same. An interesting thing that we can do by manipulating these equations is, as you see, the omega equation and the alpha equation, they both have dt in it. So that means you can solve for dt in both of these. So if you solve for dt in the omega equation, you get d theta over omega is equal to dt. And if you solve for it in the alpha equation, you get d omega over alpha is equal to dt. Now, if you set these two equations equal to each other, you find that d theta over omega is equal to d omega over alpha, which eventually is omega d omega is equal to alpha d theta. Now, I want to talk about acceleration in rotation. So you've probably heard this before, but you have something rotating, and if you look at acceleration, like say acceleration of this point P, it's going to have two components. It's going to have the acceleration tangential to the rotation, and it's going to have the acceleration that's normal. Something simple. So acceleration tangential is pretty straightforward, assuming you know the relationship for velocity. So velocity, and when it's rotating about a fixed axis, is equal to omega cross r, which is the distance. If this is a point P and this is the origin, then it's the radius from the origin to point P. And so just by taking the derivative of this, we find that it's alpha times this vector is equal to the tangential acceleration. The trickier and less intuitive one is the normal acceleration, and that essentially describes how the motion changes direction, and the equation for that is omega squared r. Overall, when you have acceleration when you're rotating about a rigid body, the total acceleration is equal to the tangential acceleration plus the normal acceleration.